All right, buckaroos and buckarettes, here we go. We're talking about this Chapter 3 test. This was practice problem number 1 on page 80. 1 on page 80. And apparently some people didn't understand that, hang on. This 80 right here is the mass number. Okay, you could write this as bromine 80. The symbol bromine tells you that the atomic number is 35. The number of protons is the atomic number, it's 35. There's no charge written here, so the number of protons equals the number of electrons. Okay, the number of neutrons equals the mass minus the protons. So that's 45. Okay? Hyphen notation, that is hyphen notation. Carbon, writing out the word carbon -13 is the same thing as saying carbon 13. The nuclear notation is spelling out precisely the number of protons and the mass. Now, the reason this is confusing probably is we don't need to write this for most of what we're doing. This is usually written in nuclear decay and radioactivity. It'd be something like, if you had uranium's 92, and you had uranium-238, and it decomposed or decayed into uranium-235. That's the enriched one, 92. Then you'd write that out, and you'd say plus, I guess it'd be 3 neutrons. Okay. But that's what this is about, is usually for radiation, for decay. But you need to know it. I ask you because it is on your SOL, and you need to know what that nuclear notation is. It's not a big deal, okay? So the nuclear symbol for carbon 13 is simply this, okay? Here, this question says you have a neutral isotope. And I added that word neutral in there. This is practice problem number 3, I believe, on page 80. And they didn't have the neutral in there. I added it in there to make sure you understand that the number of electrons equals the number of protons. If the number of protons, okay, so if you have 15 protons, that's the symbol for a proton, then what's the element? It's phosphorus, okay? It's phosphorus. The hyphen notation is just the symbol and the mass. The nuclear notation gives you the number of the atomic number, the number of protons, and the mass here. So that would be the nuclear notation. Okay? Any questions about those? All right. Now, let's take a look at the next set right here, the next few right here. And here, this is critical that you get a grip on this. They all are the same here. It says, what is the mass in grams? I gave you the unit. So you got the unit on the right, and you take the given unit on the left. Okay, so you're given moles, and you're asked for grams. The conversion factor is going to be this unit, the unit on the right, the answer unit in the numerator, and the given unit in the denominator. Okay. So this would solve every question, every conversion from mole to grams you could possibly have. All you need to do is fill in the quantity of moles and the element. In this particular case, it's iron, and it's 2.65 moles. Okay? So now we know that the grams of iron per mole is 55.85 grams of iron per mole of iron. Okay? And we always use 1 mole because it's easier. You could use 2, but you'd have to double that. You could use 3, you triple it, right? So you just take it as 1 mole, and you read it right off the periodic table. No problem. Right? Everybody understand that? So what did we come up with for an answer there? Who? We came out to 148, I believe it's 00 what? What does it come out to before you round it? 147.989. And I'd like to see this before you round it as a clear demonstration that you understand we're rounding to the three significant figures here. The answer is 148 grams of iron. Okay. Here, same thing. It says how many moles. So we've got moles here. Here it's grams of calcium. So we have grams of calcium here, 7.50. It's the exact same procedure. You're going to take the unit, the answer unit, and put it in the numerator, and the given unit in the denominator. And 1 mole of calcium is the equivalent of 40.08 grams. The grams cancel just like the moles canceled up here. So it's going to be 7.50 divided by 40.08. And when you do that division, it's 187,125 something. 574,957, whatever. And so this is moles of calcium. And again, we have three significant figures here, so we have to round this to 3. So it's 0.187 moles of calcium. Okay. Here, same thing. It says how many moles of lead. Okay. So we're looking for moles of lead. This is the answer unit, is moles of lead. The given unit is atoms of lead. Okay. So we're going to take our atoms of lead, our lead atoms, and convert it to moles of lead. And this is 1.50 times 10 to the 12, which we know is way, way less than a mole, right? A mole would be 10 to the 23, 10 to the 12. So we're off by what? 11? What is that? That's a nanometer would be the 9. 12 would be a picom. Holy mother of pearl. That's a tiny, tiny fraction. But anyway, the important thing here is we have the same answer unit in the numerator, given unit in the denominator. This is lead atoms. And again, 1 mole of any type of atom is equal to 6.022 times 10 to the 23. These units will cancel because we're going to divide by this. So we're multiplying across here and dividing everything in the denominator. And this comes out to 2.49087. And if you look at that, you can see 6 into 15 would be about 2.5. So 6 into 1.5 would be about 0.25. Okay, and this is about 0.25. And this is times 10 to the 12 minus 23, and we adjusted by moving this over. Okay, so this is going to come out to 2.49 times 10 to the negative 12. This actually would be 24.9 times 10 to the 12 minus 23, but we got to move this back here, so we make this larger here. Okay. Right here again, same thing. We're looking for atoms of aluminum, so we're going to put aluminum atoms here, and we're going to put, and we're given moles of aluminum, so moles of aluminum are on this side, and the conversion is exactly the same. Okay, exactly the same. So our conversion factor is going to be aluminum atoms over moles of aluminum, and 1 mole of aluminum is 6.022 times 10 to the 23 atoms. So what do we have here? 2.75. We multiply 2.75 times 6. Well, 3 times 6 would be 18, 2 would be 12, so somewhere between 16 and 18, and it comes out to what? Comes out to 16.5605 times 10 to the 23 aluminum atoms, but we have to move this back one place, making this smaller, so we're going to have to make this larger. So it comes out to 1.66, 3 significant figures because of this, times 10 to the 24 aluminum atoms. Okay? Everybody with me? Okay. Questions here? All right, let's take a look at the next few here. And these are all the same, and the more you work them, the more you realize that they're all the same, okay? Where did we stop there? Aluminum atoms right there. Okay? So here we're looking at number 10. Now number 10 is slightly different in that we're going to have 2 steps, okay? Or we could potentially have 2 steps. We see that our answer unit is going to be nickel atoms, and our given unit, whoops, that's not our answer unit. Our answer unit is, what is the mass in grams of nickel, okay? So it's going to be grams of nickel. And we're given atoms. Now you could take a shortcut and go straight from, like we've been doing in all the other ones, go straight from atoms to grams. We'll do it in 2 steps. It doesn't make any difference. It's easier to understand it in 2 steps. 7.50 times 10 to the 15. Again, we know before we ever start, we've got a small fraction. We've got a small fraction of a mole because this is 10 to the 15. A mole would be 10 to the 23. So we have a tiny fraction of a mole, so we're going to have a tiny fraction of the molar mass of nickel. Okay? So if we realize we need to go to moles, then we're going to put 1 mole of nickel to 6.022 times 10 to the 23 nickel atoms. So nickel atoms cancel, and we end up in moles, and it comes out to 1.2454, whatever, 3 something, times 10 to the negative 8 moles of nickel. Okay? Now I'll just extend this line out here and put grams of nickel here. Okay? So our conversion unit then is going to be grams over moles of nickel, and 1 mole is 58.69 grams, so we just multiply that out, and that comes out to 7.31 times 10 to the negative 7 grams of nickel. Okay, 3 significant figures because you have 3 significant figures there. Okay. Now here, this question is easy, but it requires some thought. So a lot of people get confused on this, but you'll see this again. Okay. What I'm hoping that you'll do, and I remember working this problem with you. I know that there's one of them early in the chapter where we did this, calculated the mass of a carbon-12 atom, but it's the same thing if you look at your units. And the difficult thing probably here is you realize your units are going to end up with a unit in the numerator and in the denominator, okay? So this question is how many grams per gold atom? Well, if it's a trick, I mean, if it's a trick, it's a trick because you're given that information. The information on the periodic table tells you that you have 196.97 grams of gold per mole of gold, and 1 mole of gold equals 6.022 times 10 to the 23 gold atoms. So you do that, reduce that fraction, it comes out to 3.2705 times 10 to the negative 22 grams per gold. Round it to 3.271 times 10 to the negative 22 grams per gold. That's why I gave you the units in the box. Hopefully it would stimulate this right here, realizing that you already have it. Now the other thing is that mass number on the periodic table can be used with grams as the unit or AMUs. If you use this number with grams as the unit, then that is the mass of 1 mole of atoms. If you use that mass number, same digits, in AMUs, that equals the mass of 1 gold atom. So all you had to do was put the 196.97 there. Okay? Now, these were worth 5, plus 5 and plus 5. So you could potentially have made a huge pickup there. In fact, we had a couple people here that had a 60 or 61 out of 50, which is pretty phenomenal. I mean, you know, it's 10 extra points to put wherever you want. Up at the beginning of the test, we had extra credit for the first 4 blocks. Okay, they only, and that's not extra credit, but they only counted for you. They couldn't count against you. Okay, so this thing will be online. You can take a look at it. You just need to practice more and more and more practice until you get this down pat. Okay, alrighty. Thank you. Goodbye.